On this lecture, I will be speaking the basics regarding prisms. So essentially, I'll be introducing prisms as optical components and speak of two different ways how prisms can be used in optics, especially from the point of view of imaging. So first of all, of course, prisms, and I will be repeating myself many times here, a prism can be used as a dispersive component, so that essentially is being applied when we are not doing imaging, but rather, for example, would be interested in making a spectrometer. And B, a second possibility of using prisms is that we would be using them as reflecting surfaces based on the total internal reflection. And there, the main benefit is that we can make things shorter, smaller in size, and also flip the handedness of our formed images. So kind of prime example that comes to my mind is an SLR camera, single lens reflex camera, and binoculars. And there many times in many configurations, you actually have prisms that are flipping the handedness. So for example, in conventional classical SLR, when it used to be the case that you actually were looking at your eye, an image through the SLR, and you actually were using the real optics and not just the kind of camera to record the vision that you're taking a picture out. There was a pentaprism that was flipping the handedness and guiding light into your eye through the SLR. And then when you were actually taking the picture, there was a shutter or a kind of a flipping mirror that will then be guiding the light into the actual location where the image will be formed into the film back in the days. And then that was how the all kind of SLR operates, and there also you have a prism inside. But basically the nice thing of using prisms and the total internal reflection is that the then broadband light will be guided as such, because process of total internal reflection doesn't really strongly depend on the incidence light's wavelength. So that would be the kind of motivation of using prisms for imaging and flipping the handedness. So this is in a short what I will be speaking about. I think my motivation talk was longer than the actual lectures will be, but let's see. So prisms can be used in many optical instrumentation, and depending on what kind of functionality we're actually looking at, their behavior can be described in two different ways that has been highlighted in the figure A and B. The first possibility is using them as a dispersive medium. So essentially that will be described in the figure A. So there we are using refraction of light, and the fact that the Snell's law depends on the index of refraction n, and since in dispersive medium the index of refraction depends also on the incident wavelength, we can separate a broadband source, a polychromatic source, into different frequency components. And then if I would be, for example, just placing a camera here, in principle, a single prism could already be used as a spectrometer, so that I can take my polychromatic light, it disperses when propagating through a prism based on the Snell's law, refraction law, and the refractive index dependence on wavelength, and then I can do these kind of things. So essentially, this is one way of using prisms as a dispersive medium. A second possibility is to use them by just utilizing total internal reflection. Let me repeat. Total internal reflection. So that you hopefully remember by me fooling around these two different conventions. And then in the second possibility, we are basically just using them to kind of flip the handedness of my image to be formed. Or I can guide light in a neat fashion, because this reflection here based on total internal reflection is pretty broadband process and doesn't really depend much on the incident wavelength, as we have already discovered at the homework exercise, I think. So this is another possibility that we can take use of prisms, so that they use them to reflect light and guide light, and this is basically how they are being utilized. So prisms, for example, then subsequently can be used if you're using them as a dispersive medium, so that we can use them similar to diffraction gratings. So basically, like I already mentioned, we can separate the different frequency components of light from each other, so that we can make spectrometers. We could also, in principle, also make monochromators, and then we could use make spectrometers based on monochromators. But monochromators essentially are just optical instrumentation that you input polychromatic light, and using the settings of the monochromator, you can choose what colors of light are propagating through. And these, when you need to do these kind of tricks, they can be very handy, and many times they're also being combined with spectrometers, and you can make nice implementation using them. And the second possibility is that you can guide or you can reflect a polychromatic, a broadband source of light with small losses. Let me try to say negligible losses. Yes, I made it. It's a very tough word to pronounce. And at the same time, you can flip images if you wish to do so. And a kind of like a practical example here, for example, would be a binocular, or like if you're interested in taking photographs, especially with an SLR camera, there you might have a pentaprism inside, which is also flipping the handedness, because basically what you have at the front of the camera, you only have a single lens, and I'm recalling how a single lens is being forming an image. The image will be inverted, so that if you want to then see through the camera how the image looks like, and you don't want to look at the inverted image, you need to flip the handedness of your vision, and that you can easily do by just having a pentaprism inside an SLR. So these two different configurations exist for prisms, and if you really want to know more, I again refer to the book, excellent book by Hecht, the optics book, and there's actually a whole chapter on different kind of prisms and the different prism configurations, and I really recommend you to look what they entail. In addition to these, we don't cover that in our course much, but you could also change the polarization state of light using prisms. So for example, you can make beam splitters, you can make polarizing beam splitters, and you can make different kind of, for example, the Fresnel rhomb is an example of a prism essentially. And then you can also make a Wollaston prisms, so that you can separate different polarization components of light. But let's not go there on introductory level course, but rather leave those kind of components and considerations to the more advanced courses. But I thank you your time and patience, and please join me shortly on the next lecture, where I will be speaking about
the human eye.